astrology. Alright y'all, our first order of business today is talking about our final projects.
Ooh.
So there's been some confusion about exactly what I want. Want to reiterate, no PowerPoint slides recorded over y'all. I do this every day, so make sure there's some animations or something in your video. Any questions?
Oh, Jeff, I have a question. Jeff, over here, Jeff.
So, no questions?
Yeah, so I read ahead to next month's reading. Could you explain what stellar parallax is?
Yeah, I guess we could talk about that. Let me just find my slide. Alright, so yeah, I have a link about stellar parallax, if I could get it to... Okay, so it looks like the link's not working, but I think this diagram will be fine. Does this explain it?
No. So hold your finger out in front of you and close your left eye. Then your right. Your finger looks like it's moving. That's parallax. Now imagine the Earth on its orbit around the Sun. Pick a spot on its orbit, then, 6 months later, it will be on the exact opposite side of that orbit. Now imagine you're looking at a specific star in space from Earth, and those 2 points on either side of the orbit are your left eye and your right eye. That's stellar parallax. When we look at a star in 6-month increments, we expect it to shift slightly in regard to its background. Using this parallax, we can calculate how far away that star is. We know how far away Earth is from the Sun. If we can measure the angle of difference between the star's position at one point in time compared to 6 months later, then we can calculate the distance of the star from Earth.
What are we learning about? Parallax. So if I was sitting in the back of the room and I wanted to know how far away sleeping kid number 4's computer was from me, then how could I figure that out?
So you knew the distance from you in the center of the aisle. We'll call that distance x, which is 1 AU, assuming you were the Earth and the center of the aisle was the Sun. Then you need to find the parallax angle, or half of the angle of change in a year. In the sky, this angle of change is extremely small and hard to calculate. You can only do it with super sensitive equipment. Given the angle, you can find the distance d. By plugging the angle into the formula d equals 1 over p, or distance equals 1 over the parallax angle, to find the distance in parsecs. Given that you were doing this on a scale of a classroom, which we've come to realize is a stupid and useless visualization, then you'd end up with a ridiculously small number.
Yeah, this is wild. Like, who's the first guy that even thought of this?
So I wasn't going to talk about that for another month, but I can pull up the PowerPoint right now that will explain the history. If I could just get it to work. So stellar parallax was first used in the early modern age by the Greeks in order to argue against the heliocentric model. They claimed that parallax should occur if Earth orbited the Sun, but they could not detect it with the naked eye. In the late 1500s, Tycho Brahe agreed with the Greeks. He believed that if the Earth orbited the Sun, there should be an observable stellar parallax every 6 months, during which the orientation of a star would change thanks to the Earth's orbit. Even though he possessed one of the most accurate tools for measurement of his time, it was not until 1838 that parallax was detected and used to calculate the distance of a star for the first time. Friedrich Bessel is credited with being the first to use parallax to find a star's distance. Astronomers had believed for some time that parallax would provide the first accurate measurement of interstellar distances. In 1838, Bessel announced that 61 Cygni had a parallax of 0.314 arcseconds, which, given the diameter of the Earth's orbit, indicated that the star is 10.3 light years away. So yeah, that's pretty much it. That's the history of stellar parallax. Does that answer your question?
Yeah, I mean, like, that just about covers it, but, like, there's so much more. Like, can you please explain some more of this to me after class?
Yeah, I mean, I always love talking about astronomy. Maybe we can go hang out at, like, King's and grab a beer and just talk about astronomy or something. Matter of fact, here,